So this time we'll look at division. In year 3, it is all about those times tables. And just like an example I've already got here, it's learning those associated division facts that go along with the multiplication. So if I'm looking at my array for 5 times 3 or 3 times 5, from this array you can derive also that 15 split into 5s, there'll be 3 of them. 15, if you wanted to find groups of 3 inside there will be 5 of them. So it's all about those division facts that go along the multiplication as well. Now I've put year 4 here, but in all likelihood at the end of year 3, children will also start to think about using number lines to help them divide and think about a method that we call chunking. So if you're going to use your number lines to divide, we start at 0 and we're chunking in this number, the number that we're dividing by. So really simple, and using your counting skills, that'll be 1 jump of 5, another jump of 5 will get me to 10, another jump of 5 will get me to 15, another jump of 5 will get me to 20. I haven't drawn my number line long enough, have I? Another jump of 5 will get me to 25. So in total there's 1, 2, 3, 4, 5 jumps. So 25 divided by 5 is 5. So even though hopefully children will be able to do these sums in their heads because they'll know their times tables really well, this is how we'd start recording our written methods for division in our books. Move on to the more formal methods later on. If I was going to do 48 divided by 4, I'm going to have to make loads of jumps of 4. It's going to take me all day. So the next step after introducing chunking a number line like this is thinking about the related multiplication and division facts they already know. For example, I know that 10 lots of 4 is 40. So 10 jumps of 4 would give you 40. And from there on, I can jump in 4s now. So 1 lot of 4, 1 more lot of 4 would be 44. Another lot of 4 would be 48, which is the number I need to get to. So in total I've made 3 jumps. This is where sometimes children can make a mistake, because up here we made 5 jumps, the answer was 5. And here we've made 3 jumps, the answer must be 3. But that's not quite right, because we haven't actually made 3 jumps. This is actually worth 10. But we've just drawn it in one go to save us a bit of time. So rather than 1, 2, 3 as your answer, it'll be 10, 11, 12. So we're making those bigger jumps to start with. So after we have done jumping in tens first, we can think about what other number facts that we know. For example, for this one, 96 divided by 3, I could do a jump of 10. 10 times 3, which is 30, and another one, and another one. But for my times table facts, I know that 3 times 3 is 9, so 30 times 3 is going to be 90. Okay, I've made 30 jumps here all in one go. And then to get from 90 to 96, there's 6 left. Now I know 2 times 3 is 6. So in total, I've made 30 jumps and 2 more jumps. My answer is going to be 32. The ideal then, even when we get up to nice big numbers, getting into sort of 3-digit numbers, is you want to be able to try and solve these problems in 2 jumps. And in year 3 and 4, you'll only really be looking at 3-digit numbers divided by a 1-digit number at the most. This final example here shows you how, using number lines like this, you can also show remainders, because there may be problems where the numbers don't divide in perfectly. Now, I could do jumps of 5, but I know 9 times 5 is 45. That I've got there. I can't fit another 5 in. Another 5 is going to get me to 50, but 47's in the middle. So there's going to be a remainder left over. If 47 was there and 50 was there, I'm going to jump over it. I've got 2 more here. So in total, my answer is going to be 9, remainder 2. Now, you might see that written sometimes as 9 and 2/5, writing the answer as a fraction. And both answers are perfectly right, because you're dividing by 5 and there's 2 left over, so 2 out of 5 is left over, 9 2/5. Okay. When we get to year 5, we're then moving towards the more formal written method. I've done this one already, very Blue Peter style. Here's one I've done earlier, for 48 divided by 2, and I've said that equals 24. So, in this example then, I've already done my jumps of 20 lots of 2 and my jumps of 4 lots of 2. If I'm going to then put this into a bus stop method, because it looks like a bus stop, you put the number you're dividing by on the outside and the number you're dividing on the inside. And just like when we looked at multiplication, we're doing the same calculations as we've done on this number line. We're just making it more efficient. So 2 into 4, well technically actually this is 2 into 40, because that's the tens column, that's the units column. 2 into 40, I know, goes 20 times. There, so in my tens column, I can put the 2 because it's 20. 2 tens is 20. From here, I can then go, well, how many more do I need to jump? I've got 8 here. How many 2's going to 8? Well, that's 4. Simple. So I've done exactly the same calculations to get exactly the same answers. Here's another example below. This time I'm dividing 329 by 6. So 6 into 3 doesn't go. I could put a 0 there, or I could just move on. So 6 into 32, I know that goes 5 times. 6 times 5 is 30. I've got 2 left over though, so I'm just going to put these into the next column. So for this next column, the 2 goes across. It's now 6 into 29, which I know goes 4 times. There's still 5 left over, but there's no other columns to turn it to move that 5 into. So again, that's my remainder, just like we looked at before. Or if we were going to write that as a fraction, your answer would be 54 and 5/6. In years 5 and beyond, we would encourage children to give the answers as fractions rather than just remainders. In year 6, this short division method will be used again, this time looking at dividing numbers that involve decimals and dividing those by a 1-digit number. So I've set it all out, and just like any other time I've done a written method with decimal points, I'm going to keep the decimal point in exactly the same place. I don't want it to move. So I'm going to start like normal. 5s into 7 go once with 2 left over. 5s into 29, I know that goes 5 times. I'm going to have 4 left over this time. And 5s into 42 go 8 times. The problem here is I've still got 2 left over, but I've got nowhere else to put it. Because it's a decimal problem, like I say, there's 9 tenths, 2 hundredths, and there's no thousandths, so I could just put a 0 in there. In fact, I might put a few more zeros just in case I need it. Just extend that line a bit. So 5 into 42 we said was 8 times with 2 left over. 5s into 20 is going to go 4 times. And there's nothing left now, so I didn't need those extra zeros, but there's no harm in putting them there. So keeping that decimal point in the same place, I can use my bus stop method to solve decimal problems as well. Now, turning over to the last division written method we do, it's everyone's most favourite, I'm sure, is the long division. Now, if you've looked in our calculation policy, which hopefully you have if you've found your way to this video, we've talked about McDonald's, which is a bit weird, but it's a really good way of reminding children there's different steps to solve long division problems. Does McDonald's serve burgers? Or, more accurately, mathematically wise, divide, multiply, subtract, bring down. These are the 4 steps you need to do to complete a long division problem. Sometimes you might need to complete them more than once, and we'll go through that in a second. But this is important because it's a step-by-step guide. Long division is quite fiddly, but it's actually really simple. Once you just work your way through the method a few times, you'll get used to it. The maths isn't very hard, it's just fiddly. So with a bit of practice, a bit of overlearning, you'll be fabulous at it. So this problem here, 4,640 divided by 32. Now, I don't know my 32 times table off by heart. I don't know if you do. If you do, congratulations. So I'm just going to make some jottings down the side just to help me remember counting up in 32. So my 32 times table. So 32, 64 would be the next one. So 2 times 32. 96 would be 3 times. Right, if I had another 32 on, it would be 98. 3 more 10s would be 128. Get to 130 for 2 more, so then 160 once I had those 10s on as well. 192, let's do 1 more, 192, 194, 224. So each time as I've gone down, I've just added 32. And essentially I've got 1 times 32, 2 times, 3 times, 4 times, etc, etc. Okay? So those jottings are really important. Definitely encourage all children to use those to help them solve their long division problems with as little issues as possible. So, again, I'm going to put the number I'm dividing inside my bus stop. I'm going to put the number I'm dividing by on the outside, and then I can get started. So the first step is divide. Basically, how many 32s go into, well, it would be 4, but you can't fit any 32s into 4. So let's go across to the 2 numbers. How many 32s go into 46? Now, it's only 1, so I'm going to put a 1 there. That's my divide. Okay. This is where the jottings comes in useful, because I know that 1 times 32 is just 32. So 32, I'm going to write that below because I've multiplied it back out. Multiply, sorted. Right, I need to know what's left over. So I'm going to subtract. So 14, take away 32 is going to be 14. I already said the answer by mistake, didn't I? 46 take away 32 will be 14. That's my subtract. And then finally, I'm going to bring down from the next column the 4, or the 40 from the tens column is going to go there. So 144. So now you can see I'm lined up, ready to go with the next column. So how many 32s go into 144? So, oh, that's too far. So it's going to be here. So it's going to be 4 32s go into 144. That's my divide stage done. Now, I knew that 32 times 4 was 128. So I'm going to multiply that. There you go, that's my multiply stage done for the second time. And again, I'm going to have to do some subtracting now. So 144, I'm going to have to borrow from there. It's 6, 1, just 16. Lovely. And then I've done my subtract. So now I need to bring down the last 0. Here we go. And now I'm going to start at the top again. Now, I've got 160 left over. If I go down, that is 5. Perfect. So it goes in 5 times, and if I multiply it back out, it's 160. And if I take that away, I'm going to get 0. So this is how I know I am finished. You might end up with a number there. If this was a slightly different sum, you might end up with a smaller number there, something you can't fit any more 32s into. That will be your remainder. And there's examples of that in the calculation policy as well. But for this example, I've just worked through that divide, multiply, subtract, bring down a couple of times. Sometimes you won't need to do it quite so much. Sometimes it might only take once or twice to work your way through. And I found myself my answer, 145.